Good afternoon, friends. So we will be heading to our next topic, dimensional analysis. So when we say about dimensional analysis, we have to term about the dimensions. So dimensions or the technicals, we have say the units or basic parameters in which we may be measuring the terms. Example, length is a dimension in which we will be measuring with several terms like meter, centimeter, inch, etc. So in terms of time, we will be measuring with second, hours, minutes, years, etc. So all these parameters are time. But and mass in terms of kilogram, gram, kilogram, pound, etc. is being used for measuring the mass. So these are the basic fundamental dimensions which will be represented using length by L, time by T, and mass by M. So these fundamental dimensions are used for calculating many other derived units. Fundamental units is 3, and for that we'll have fundamental units. With this 3 fundamental units, we have derived units, several derived units here which we have to study. So we will be having the velocity, acceleration, viscosity, etc. So we will see the sum of the fundamental major dimensions. So in fluid mechanics we will be using several dimensions. The first one is velocity, and so we'll be using the dimension in terms of meter per second. The units will be very important for fluid mechanics. So I will have written the velocity, which unit is meter per second, and its dimension is meter is length, so L, and time is T, and denominator power minus 1. Acceleration meter per second square, L T power minus 2. Force in terms of Newton, so which is nothing but mass into acceleration due to gravity. That acceleration becomes meter per second square, so kg meter per second square, which in terms of dimension L T power minus 2. So similarly there are several units which needs to be studied in the fluid mechanics. So we have the several dimensions. So what is the importance of this dimension analysis in this our current topic is, so we have derived units, say velocity, acceleration, discharge, etc. There are several millions of several thousands of units we have derived till now. And what's the importance of this dimension analysis is, when we want to derive a relation between two terms. Example, we want to derive the relation between discharge and density and velocity. If you know that, if you know the dimension analysis will automatically give you certain relations between them, and it will be helpful in predicting the results. So when it will be also helpful in predicting which factor will be predominant, which should be considered and which should be neglected. So all this has been with the use of dimensional analysis. And so for a dimensional analysis, we will go with a major term called dimensional homogeneity. So what is dimensional homogeneity is nothing but the dimensions will be of same power will be equal. So we have different rho v a. So the dimension homogeneity, what is the uses is, it will helps in the dimensional analysis. So you say the discharge is in right hand side will be related with rho v a, and it will have some power, so c. So we'll be having our power a1 b1 c1, because we know that we don't know the what's the value of a1 b1 and c1. So when we have when you equate this dimensions, it will bring the relations. This dimension homogeneity refers to, say, the discharges meter cube per second. So it is L3 power T power minus 1. Rho is kg. Kg is m mass, kg per meter cube. L T power minus 3. Velocity is L T power minus 1. Volume is L square. So when you say the dimensional homogeneity says the sum of powers of each term on the left hand side should be equal to the right hand side. So it is so if I say this L cube T power minus 1, is that it is possible if I say that Q discharge Q is equal to rho QV into A. So we can say m term power A is here. So m power 0 here. Nothing is there, means it's constant. M power 0 is 1. So which when it is multiplied, it is constant. L power 3 is equal to L power minus 3A plus L power B plus L power 2C. Sorry, multiplication terms, which is equal to 3 is equal to minus 3A plus B plus 2C. And time factor T power minus 1 is equal to T power minus 1 minus B. So which is equal to B is equal to 1 and is equal to C is equal to 1, and we got A is equal to 0. So the dimensional homogeneity says the left and right side have the same dimension. So in this case the density rho is having a power 0, that is the density is not having any influence in the volume flow rate. So this will help you to predict the results. So what will be the output? So this is a dimensional homogeneity analysis. So we have for this analysis of dimensional, we have two methods. One is Rayleigh method and the second is Buckingham's pi theorem. So first one, Rayleigh method, is we will be using the Rayleigh method is used to derive relations between two different one by the same dimensional homogeneity, which we have simply solved right now. Okay, this method of solving the dimensional homogeneity say the powers, sum of powers at LHS is equal to sum of powers at RHS. So this equation, sum of powers is equal to LHS is equal to sum of powers at RHS, is a dimensional homogeneity equation, and the solving using like this in this method is called as a Rayleigh method. So one major disadvantage of Rayleigh method is when we have more than 4 variables, say we have the Q, V, A, and if we have another 4 terms, so another 4 like gravity, head and power. So if you want to find the relation between using this for finding the relation, we have the 6 variables. The Rayleigh methods become very complex. So we have to, it is because we have to solve 5 equations of 5 unknown with 3 equations, which is highly intermittent, and we have to write it in terms of some other terms which is very complex. So in order to reduce this complexity, we will be using the Buckingham's pi theorem. The Buckingham's pi theorem is an extension of Rayleigh-Ritz method, and it also uses Rayleigh methods to solve and find the dimensional analysis between them. So first, the Buckingham's pi theorem involves 5 steps. First one, you have to find number of pi terms. So this is a dimensionless analysis. The Buckingham pi theorem is a dimensionless analysis. So the pi term which you are selecting is having a power of 0. If there is m power l, l power l, and t power z. So you have to find number of pi terms you have to first solve and calculate. And you have to select, next one is selection of repeated variables. You have to select a repeated variables, so which that will help you in solving, and then writing pi term equation, and fourth one, solving pi term using dimensional homogeneity, and fifth one, writing the relation in terms of pi term.